here we look at the 0 times infinity indeterminate form. If we reduce it to 0 over 0 or infinity over infinity, then we can apply L'Hopital's rule. And that's what we're going to do. Let's look at these two examples. The limit of x times ln of x as x tends to 0. So that makes this x go to 0. And the ln of x will go to negative infinity as x tends to 0, because this is the graph of ln as x tends to 0 from the right. This goes to negative infinity. So this is 0 times infinity type. And we can reduce it simply to 0 over 0 or infinity over infinity type by moving one of the two factors into the denominator. So in this case, I'm going to keep ln of x in the numerator, and then x in the denominator would be 1 over x as x tends to 0 from the right. Now the numerator goes to negative infinity, denominator goes to positive infinity as x goes to 0. So this is infinity over infinity type. So we can apply L'Hopital's rule. And by L'Hopital's rule, this is the same as the limit of the ratio of their derivatives as x tends to 0. That would be derivative of ln of x divided by derivative of 1 over x. Then we get the limit as x goes to 0 from the right. Derivative of ln of x is 1 over x. Derivative of 1 over x is minus 1 over x squared. Then we can simplify this to the limit as x tends to 0 from the right of minus x, and that is 0. So now let's look at this example. This one is x times e to the minus x, and x goes to infinity. So this x goes to infinity, but the e to the minus x goes to 0. The graph of e to the minus x is like this. As x tends to infinity, this tends to 0. E to the minus x goes to 0. So this is infinity times 0 type indeterminate form, and you need to rewrite it as 0 over 0 or infinity over infinity, so we can use L'Hopital's rule. So L'Hopital's rule can only be applied to 0 over 0 and infinity over infinity directly, but other types of indeterminate forms can be reduced to those two simple types. In this case, I'm going to move e to the minus x to the denominator, so keep x in the numerator. Then in the denominator it becomes e to the x. Now, the numerator goes to infinity, denominator e to the x goes to infinity as well. So this is infinity over infinity type. Therefore, I can use L'Hopital's rule, and by L'Hopital's rule, it is equal to the limit of the ratio of their derivatives, which is the same as the limit as x tends to infinity of 1 over derivative of x is 1, derivative of e to the x is e to the x. And now take the limit again. E to the x in the denominator tends to infinity. So we have 1 over infinity, which is 0. The limit is 0. There will be more examples in the next video.